Hello, is my screen visible? And am I audible to everyone?
Yes.
Thank you. Okay, so let's get started. Thank you for joining. So today we are going to discuss notification service system design. Okay, so basically not a service. One second. Still, I'm seeing a lot of people are joining. One second. System. Okay. So this is the topic for today. I think we can get started now. Okay. So let us understand firstly that what are we going to study today. So like I told, we are going to study notification system design. So the requirement for today's problem, and today's problem we will be doing in an interview format, just like how do you do it in an interview. So the question is, which I have given, and what you have to solve is you need to create a notification system which does mobile app notification, SMS notification, email notification. Okay. So you have to support, this is generally called push notifications that you see in your iOS or Android devices, the push notifications that you get from any company, SMS notification, email notification. Now, a good thing to understand here that this is not a product, this is a component of any company. So, for example, let's say you are Swiggy, and in Swiggy, there are multiple things. Let's say there is an offer going. So, you will send notification to your customers. In Swiggy, if your order has been delivered, then you will send a notification. If the order has been prepared, then you will send a notification. If the order has been cancelled, then you will send a notification. So notification system is that piece in every company which is responsible for notifying end customers through app notification, SMS or email. Okay. So I hope now the problem statement is clear. What are we today going to design? So this is the problem, right? That we are trying to design a notification system. Types of notification have been told, 3 types. So now we will do it in an interview format. So for example, let's say if I'm sitting in an interview and this question has been asked to me, then firstly I would try to question the interviewer to gather the requirements that he has in mind and to clarify further on the requirements of this question, the scale of this question, and a lot of things. And then we will try to collate what all requirements are there with us, and then we will try to come up with a system design for this problem. Okay. And if there are any questions, feel free to type it in chat or ask me. Happy to answer. So let's get started. So, what are the questions that you may have when you listen to this problem statement? Right. So of one question which has already been answered, like what are all different type of notifications that we need to support, which has been written: mobile, SMS, and email. What other question? Other question which I would be interested in, like how much latency or how much real time notification do you need? Like, is it real time notification? Because some notifications are real time, which will make no sense if they come outside of that time limit, right? So again, in this system, we will try to have a latency that is acceptable. So of course, we don't want, because this is a notification system. For example, a bank OTP notification system that is highly real time, right? If that is not real time, a lot of things will go bad. So our design is not on that line. Our design is for notification system, general notification system, which any company can use their customer for promotions, offers, and notifying about other things. So there the latency does not need to be real time, but it has to be. For example, you ordered something on Swiggy, order got delivered today, and you give a message tomorrow that congratulations, your order was delivered. This is bad. Of course, I don't want to take the package from the delivery guy, and at that instant only, I'm not expecting that the message will come. Delivery has happened. So there is some acceptable time limit here, which is not real time, but the latency should not be too bad. So here you can roughly think like 5 minutes from the moment I want to send, once I show the intent that I need to send this message, within 5 minutes, if the message has been received, it is good. That's a good system, notification system for me. What else can be questions that you may have? What devices are supported, right? You can send notifications as Windows notification, as mobile notification. So the answer for this is you need to support iOS, Android, laptop, desktop. Okay. So phones, both iOS and Android, and then your desktops and laptops. Both have to be supported. One question somebody has, how many users need to be created good? Yeah, that will come to that also. What is the scale? Right. What is the scale that we are talking about? So scale here, let's say, is 10 million push notifications, 1 million SMSs, 5 million emails. So per day, daily. This is the scale that we are dealing with. Also, one more interesting thing, like who triggers the notifications? So the answer here is that it should not be a concern who triggers. Like we are a notification system. We have to expose some APIs on which people can send their request, which they want to send to customers. Of course, we'll need the customer information and the message that you want to send, and then we should be able to send. So here answer is it can be either client side or server side. Should not concern us. Our main role is to handle the request that we are getting and cater it to the customer. So it can either come from our clients or it can come from internal services. By server side means internal services. For example, billing service can ask notification service to send notification once the billing is done, something like that. Okay. Another important feature here can be, do we want to give opt-out functionality? Right? Opt-out functionality as in, let's say there is a customer, he is fed up with our emails, he wants to opt out. So do we offer opt-out functionality? Answer should definitely be yes. We need to support opt-out functionality. Okay, so these are some questions that you may ask. So let's go through them. Latency is important, but we are not focusing on extremely real-time latency. So 5 minutes is good for us. Now, what else? Supported devices, scale, let's estimate what will be the throughput, etc. What else? It can be triggered by anyone. Okay, it can be internal service or it can be customers itself. What else? Opt-out functionality. Yes, we need to support opt-out functionality. So now let us prepare a list of requirements. So let's prepare the requirements. So we need to send notification, and scale that we are catering, we know, is around 10 million, 1 million, and 5 million for the three categories that we have. Latency is, we can compromise a little over latency, which means availability has to be high, but it is not a very hard requirement. So latency is up to 5 minute delay. For example, like Swiggy wants to send you a message once delivery has happened. If that message reaches you within 5 minutes, then our SLA is good. Okay. What else? We need to give opt-out functionality, and then anybody can raise the request. That's a clarifying question. That's it. Okay. And devices supported are iOS, Android, and laptops, desktops. Okay. So these are some requirements that we have. Of course, first requirement that now we will come to some other non-functional requirements. So these are functional requirements, functionality wise. Now let's see non-functionality wise, what are the requirements? Availability, which means your system is always up and running. Availability should be high here. Consistency, I don't see a use case here. So consistency is not important in this case. Consistency will not be a question because there is no updates or writes kind of happening here. We are getting a message which you need to send. So consistency is not a point of concern in this problem. What else can be non-functional requirements? Latency, you already know that we have already written. Latency is like we have our limits there. What else can be non-functional requirement in this case? Uh, Reliability needs to be high. Reliability means if I sent a message, it should be sent. Okay. For example, if I'm sending a coupon code to a customer, it definitely should be sent. It should not fail. Okay. So reliability slash robustness. What else should be a requirement? Non-functionality requirement, like unsaid. So let's say you are a consumer of my service and you received absurdly high amount of emails or messages or SMSs from us. So you would be irritated and that would lead to drop of our customer base. So here we need to also make sure that we rate limit notifications per client. Per client or per device? That's a good question to think about. One client can have mobile, desktop, laptop. So per client, you want to limit your notification or per device. So if you think carefully, it makes sense to have it per client itself, right? Once you have notified someone through one channel, that's okay. So, okay. That is a choice that you can make. Per client or per device, whatever you choose, it's a objective thing. Both are fine. Okay. Depends what is your threshold. Threshold is very low, then it must be on a device level. If it is high, then it can be on a client level. Any other non-functional requirement? Proof of notifications, persistence of notifications, and other proof. I think a good point here. Basically, we should have logs, analytics, metrics. What are these? Logs. If a message failed, then we should have proper logs in our system to know where it failed. Analytics. If I have sent X amount of messages to my notification center, how many went through? How many failed? Then where did they fail? Did we not send them? Did the customer not open the email? Right, something like that. Metrics is also again the same thing. So basically, we want that everything. Like we send a message. Firstly, we try intend to send a message. We actually send a message. Message can either fail to be sent because something is wrong. Let's say a mobile number is wrong or whatever. Message can be received. Then has the customer opened that or not? Has he clicked on it or not? All of this comes under analytics, which is a good to have. I would say this is an optional design feature that you can have. If you design this, you will get some bonus in your system design interview. Otherwise, all other things are absolutely important. Scale, latency, opt-out functionality, uh, platform support, availability, reliability, rate limiting, and then optional feature that we can have some good mechanism to have logs, analytics, and metrics on whatever messages you're trying to send. So this is how you come in a conclusion with respect to the requirements of a problem that we are trying to solve. Okay. And once you get an idea about the requirement, then you can start thinking about it. So the next step here is to identify the real hard problem here. Okay? So people generally jump straight away designing generic system with a load balancer and whatnot. But rather, you should see which problem here is the hardest problem to solve. Scale. Let us do the estimation first. Is it that bad? Let us keep 10 million because rest are less. So 10 million per day, which means 10 million, 1 million is 10 to the power 6, 10 to the power 7 notifications per day. One day has 24 hours, which has 60 minutes, which has 60 seconds. This is 10 to the power 7 divided by 24 times 36 times 100, right? What would be 24 times 36? Now we are estimating, may not have a calculator every time. Just do 25 times 35, right? Instead of 24 times 36. What number do we get? Quickly, you can get that number. That's 875 times 10 to the power 2. This is 10 to the power 7. This will roughly come out as 10 to the power 5 divided by 875. Again, approximate 875 as 10 to the power 3. So that will come out as 10 to the power 2 per second. This is coming out as 100 requests per second. This is for 10 million. For 10 million, it is just 100 requests per second. So 100 requests per second is a good scale, not extremely high scale. Okay. So now scale wise, let's note. So for push notification, it was 10 million, boils down to 100 requests per second. Now we will scale it for the email and SMSs. So for SMS, it is 1 million. So for 10 million, 100, then for 1 million, it will be 10. Simple unit mathematics. And for email, it will be 5 times this, 50 requests per second. Okay. So these are the numbers that we are talking about per second. And a good idea here for you guys to take here is that if your requests are, depends on your request also. So let us understand this. If it is a simple compute, then it is not a very hard thing to scale to up to 1,000 requests per second, something like that. But here it is not a very trivial job that we are doing, right? You are trying to send a notification to some client, right? So depends how you design it. That will determine that your request is expensive. One request is expensive or not. Okay. So we need to keep in mind that we will have 100 requests per second, and we have to design a system in accordance to that. And it will determine what all things we can do in one request. Okay. What all we should do asynchronously, what all we should do sequentially. So that all things we need to take care. Now, these are our back of the envelope calculations, which we get. Yes, one question had been asked, do we need to do it? Yes, you should do it. And we already did that. Now the next question which I was, identify the hard problems here that you have to solve. Okay. So sending notifications on desktop and laptop via email or SMS is like, there are 3 notification channels here. SMS and email, we'll come to that, how to do it. But mobile push notification is something we need to invest time on. How do we send requests on iOS devices or Android devices? That we should have some idea. Okay, and here is something that you all should know, that how push notifications work. So if you don't know about this, it will be hard for you to design, because email sending is easy. Email sending can be automated, right? We have a lot of third-party services like SendGrid, MailChimp, which can send emails. SMS, for SMS, we have Twilio. Again, SendGrid also sends SMSs. So SMSs is also fine. But how push notifications, etc., work in any mobile? So let us try to understand this. In iOS mobile, if you want to send a push notification, so this is not a system design that I'm going to do. This is the basic information. This is informational content for so that you know how push notifications work. This is how push notification works. There is a provider. Provider is basically, you can think of it like he's the person who wants to send notification to the customer. Okay. So he wants to send notification to clients via iPhone, iPad, whatever, right? XYZ. Okay. Via some Apple platform, he wants to send something. So provider wants to send something. And then there is something called APN, Apple Push Notification Service. So provider has to send its request to Apple Push Notification Service, and Apple Push Notification Service has two mandates. It needs device token, which is a unique identifier for your device, and it needs the payload. Payload is basically the message. It has the message and HTML and whatnot. Like you get a small image, some text. So this is your payload. Device token uniquely defines a device to which the notification has to be sent. So these two things are needed by today. You want to send a push notification to your mobile, you can do that. All you need to do is have a device token and prepare a proper payload, which is understandable by iOS devices. Okay. So from here on, it is the entire Apple ecosystem. Okay. That will take care of the push notification. All you need to invest time on is getting the right device token and the right payload. And after this, of course, you will get the notification on your mobile phone, iOS mobile phone or iPad or whatever. You will get the push notification. I think push notifications only work in iOS and iPad. Rarely I see desktop notifications etc are configured on laptop. So mostly we are talking about handheld devices where push notifications are a main concern. So this is something that you should know, that as a provider, all you need to worry about is the device token and payload. And there is Apple already has its own APNS, Apple Push Notification Service, which solves this problem. So Apple does it. What about Android? So Android also has a similar thing. Instead of APNS, they have something called FCM. What is FCM? FCM is basically Firebase Cloud Messaging. This is by Google. Same thing in this diagram, add FCM, and this works for Android devices. Okay. So these two things we should know properly, that APNs and Firebase Cloud Messaging, both of them, these are terms that you need to know if you are designing a push notification service. Rest all I think we can catch up. So this may be a knowledge gap which can work adversely for you in this question. So that's why I clarified that before. Now let's see. So now we know that for push notification, we know that we have APNS and then we have FCM for our Android devices. So this solves the push. What about SMS? So for SMS, I said there is something called Twilio, which is another company, which is a third party. Basically, today, if you want to send a message, you won't go through the grill of like creating your own connector which sends a SMS. So you have third-party services which do it for you. So for SMS, the most famous one today is Twilio, and then for email, the most famous one is Mailchimp and SendGrid. So a lot of you would know about Twilio, SendGrid, and fewer of you would maybe lesser people know about APNS and FCM. So these are the third party. These are the third party services that we will leverage to send our notifications to all our clients, whether it is push notification, whether it is SMS notification, or whether it is email notification. Our work in this system design is to design a system that uses this third party app and solves this problem. Sounds simple? Let's see how things get unfolded and how easy or how difficult this problem can be. Okay. So now let us, with this much data, let's try to see that. Let's make a very simple system that we have a notification system which is getting queries. You are simply forwarding these queries to the correct channel, APNS, FCM, Twilio, or SendGrid, and then they are sending messages. What are the challenges we see in this design? Design number one. Let us start with this. Any challenges that we see in this design? Anybody wants to take a try? What are some challenges that we see here?
We have to rely to third-party people like APN for Apple and FCM for.
Yes.
So we won't have any control, and we can't customize anything.
Right. So that's a good point. The point being made here is that you don't control the latency, availability, or scale of these services. They are what they are. You are a customer, so you need to design in a way that you are compliance with these third-party limits. You are in compliance with that. If your requests are increasing, then you need to change your strategy. Okay. So here, first problem is that, as you can clearly see, that your notification system is getting request, forwarding the request, and once you forward the request, notification system has to also tell that whether the request has been sent properly or not. So these, all of these providers, they send the message and give a response. So you need to also wait for the response. So one request is going through APNS or FCM or Twilio or SendGrid. They are sending the request to the client, and then they are returning you the response that whether the send was successful or not. And sending a request to a client is, especially email or SMS, is not as quickly as sending a API request or HTTP request. This is not HTTP request. So here, first point is that one request is expensive. Secondly, you don't control latency of third-party services. With these two data points, what is a bottleneck in notification service? Can anybody tell? So one request is coming, you are sending it to, let's say, Twilio. Twilio is sending it to the customer. Then Twilio tells me that yes, request has been sent. This is a lengthy process for one request. So what is the first obvious challenge that we will have in notification service? Right. If you have done the previous classes, you will get an idea. If one request latency is high, then it has an exponential impact on availability. Why?
If it is a synchronous, then it's a problem. But if it is a asynchronous,
Currently we have kept it synchronous.
Synchronous.
So it is a problem, right? Like you mentioned. And why it is a problem? Because if one request is holding that thread for, let's say, 5 seconds, and you are getting, so if one request is being held in one thread for 5 seconds, which means a lot of parallel threads will be running in those 5 seconds, right? Because request coming into your system is not reducing. People will keep querying you, and one request you are taking 5 seconds to serve. So simple analogy is, let's say you are eating food on a plate and somebody is giving you more food, and the amount of food you are consuming is less. The rate at which you are consuming is less, and rate at which they are giving is more. So here what is happening? Overflow can happen. Availability can drop. Why availability can drop? Because most of your bandwidth will go in serving requests. And a lot of requests will again come. So CPU spike will happen in your system. Had this 5 second been 5 milliseconds, then the game would be completely different, which means a request is coming, gets served in 5 milliseconds, and that thread is free to take another request. But now one thread is blocked till 5 seconds, which means a lot of parallel threads are running in your server, which means server is running in a lot of load, and we already know that we are getting 100 requests per second. So this can become a bottleneck for our service. Okay, we can scale, but tomorrow, let's say, so today the scale is 10 million. Tomorrow, let's say we want to 10x it, then the horizontal scaling will be quite costly here with this design. Also, it is quite possible that you start dropping requests. Okay, because you are taking a lot of time, so you don't have. So let's say the CPU utilization right now is 100% with so many parallel threads, and one more extra request comes. So this extra request will get dropped because the notification server is not available to take this. This means availability takes a dip. This is a thumb rule. Availability takes a dip when latency increases. Okay, so whenever latency increases, one obvious judgment that you need to make is that availability is going to dip because of these three reasons. Latency becomes high, a lot of threads in parallel start executing. Because a lot of threads are parallel are executing, number of cores are fixed, CPU utilization peaks, which means CPU is not available to handle new requests, which means availability is down. So one by one, this is how the impact happens on availability. That is one thing. Another problem here is that, let's go back. Yeah. Another problem here is that this is a single point of failure. So our notification service is a single point of failure right now. If anything goes down here, then the whole system goes for a toss, which can happen. Another problem here can be that it is a performance bottleneck as well, right? Like we have seen. So all of three are related, and all of them are related to this point, that one request can take a lot of time, and we are getting a lot of parallel requests. So we become a single point of failure, we become a performance bottleneck. So we need to think of another design. So this simply this design won't work. So like somebody said that we can make it asynchronous. So how do we make something asynchronous? What can we change in this design so that notification service becomes scalable? Today it is not scalable, can't handle so many requests. And the most important reason is this 5 seconds that I'm taking per request. So how can you? Yeah, somebody was saying something.
Message queues.
But how will message queue help you save the processing time of 5 seconds? You are on right track. What is the why? Just the logic.
So we can send the request, and then the response.
Firstly, where do you put the message queue? So let me draw the diagram. You have notification service, and then you have these are your third-party apps, which I will not draw again. Third-party apps. You need to choose the right one for your use case. That selection is happening, and then there are multiple services in your own company which are leveraging your notification platform to send messages. So this is the flow. Where do you fit a message queue? I see two places. So where message queue goes? Here or here?
So wherever the request is coming, so there S1, S2, S3 are coming. So those requests can be in a message queue.
Okay. So let's say let us do this one by one. So let's say one design is that you put a message queue here. Okay. So if I put a message queue here, which means all the services send messages in this queue, and notification system starts reading from the queue. And still this is happening. This process is still happening sequentially, correct?
Correct.
So what is some problem that you see here? Can you guarantee latency of 5 minutes? So for example, you are taking 5 seconds per request, and let's say this will pile up. Of course, that's why you have created a queue, because notification service has more on its plate. So basically, what a queue does is, imagine the same problem. I'm having food, and somebody is giving me food from one side. I'm eating, so I'm consuming at a rate, and I'm getting it at another rate. Whenever there is a mismatch in this rate, that the rate at which food is coming in is higher than the food is going out, then messaging queue acts as a buffer, right? You can imagine like another plate, to help me take my load from my plate, okay? And I will then eat from this plate whenever I get time. Okay, in my own time, I start eating that up. But that means that latency will go for a toss, right? The last message in this queue can be delivered after 5 minutes.
Actually, my understanding is third-party APIs, they give option of either asynchronous call or a synchronous call, right?
Mhm.
So if they are giving asynchronous option, then this issue will not be there, right?
No, so not all third-party apps will do that, because that is not in your control. For
Okay.
example, Twilio SMS notification is not asynchronous. Neither
Okay.
is your email notification. And for example, even your push notifications are not asynchronous. They also, you send a request and immediately it reaches our mobile. So all of these are not asynchronous. As in, you send a notification to them and they will get back to you, saying that okay, request has been sent. This won't work in an integrated fashion, because firstly, for example, let's say they want to support it.
Hmm.
So I send them a request and they process the request. Now they need to send me the response back, right?
Hmm.
So now they are acting as a server and I am acting as a client for this, right? Which is not a very typical thing, right? No, I am a server. My responsibility is to compute and to return responses. Now I am receiving a response from here. So that in itself is not very easy, if you try to think about it, because now my server is also acting as a client for the APNS, and then imagine the kind of load that these guys are having. They will have a lot of requests coming in, and a lot of requests will be going out asynchronously. So point is that today these are not asynchronous. They don't support
Okay.
asynchronous
Okay.
methodology to send the requests. So now how do you design your system to make sure that your latencies and your reliability is kept?
Hmm.
So firstly, you added a message queue here. So we see the
Hmm.
concern. Let's say we add it here. Then what is the concern? Let us see. So now your requests are coming in. Request, what kind of request are you getting? Firstly, what will the request contain? Firstly, they need to contain the client info, right?
Correct.
And then payload.
Correct.
Two small things are coming, and let's say they are, this message queue is not there. Direct API call is happening. And now if I simply accept the request and dump it in the messaging queue, how much time will I do? I take a lot of time per request? No, because I'm just taking the request and creating a message and writing in my messaging queue. So my compute time reduces. This is very important. So where to place a messaging queue? So you try to place a messaging queue there where you can offload your compute. So you receive the request, there we can also offload that responsibility if the requests are too high. Let's say that's, for now, let's assume I'm directly getting that as API response. But now my response time is in milliseconds, because I am not directly dealing with third party apps. That somebody else has to do. I have a I am just taking the request, packaging into a message, and writing in my messaging queue. Simple. This won't take a lot of time because everything is happening in one data center, and hence this is going to take much less time. So let's explore a little bit more on this design. So what is this design? That there are many services which are sending a request, a notification service is receiving those requests and making it in a messaging queue. Now what else? Now we know that there is a third party layer from here on that we have already known it. So now we push it in the messaging queue. Now somebody has to read it from here and send it to my third party apps. And this thing has to be scalable, right? Why? This whoever is consuming from this messaging queue, they better do it very fast because I still have my 5-minute latency. So see how notification service offloaded its responsibility to a question mark here. We will come to that. What is this? So now notification system's only responsibility is to take the message and put it in the messaging queue. What else notification system is free to do now? So note things here. I can validate requests. Yes or no? I can validate if client information etc is correct or not. What else? Now notification system can also fetch client information. For example, now services can only give user ID, and then if it is a push notification, then fetching device token for this user ID, or if it is a SMS notification, then fetching phone number for this user ID can be done by notification service. So fetching client info, detailed client info can be done by notification service. They can
rate limit also.
Good point. Coming to that also. So now it can have a cache and a database for multiple purposes. One is for fetching client info. What else? Now let's go back to our requirement because we still have to solve all of them. So scale we are still solving. Okay, one part was messaging queue. Let's see what else. Latency we are still solving. We are yet to solve. Opt out we are yet to solve. iOS and Android we know how to deal with them now. So this is covered. Availability consistency now coming on reliability and rate limit. Okay, we will come to the 8th if we have time in the end. Now let's discuss about these two things. So rate limiting. Now rate limiting is basically one client is getting X amount of request per hour, per minute, per second, per day, per year that you need to define. Basically, if you have done our rate limiter class, then you know it needs X upon T. Now T also you define what unit of time. It can be 1 year, 1 day, 1 second, and X is the request. That also you need to define. So how many requests per unit time? And then rate limiter algorithms we have already discussed, token bucket, sliding window, leaky bucket. Any one algorithm you can pick and you can solve this problem. So rate limiting is something can be done here. How it can be done here? So let's say I do it at a client layer. So I'm getting user ID. So for each user ID, I will track how many requests have come. And if that breaches the threshold, I start dropping them. Okay. I return error code to these services. Quick reminder question. What error code do we send when somebody is rate limited? Anybody remembers?
Too many requests.
What is the HTTP error code for that? Does anybody remember this? 429. Okay, it is no, it is 429. Okay, HTTP status code is 429. If you have been throttled. If you have been rate limited, it is 429. So the 4 series. Okay, I'm talking about HTTP status code, not the BMW. So 4 series is for not available, 4XX we call it. It is in the domain of being availability. Okay, in domain of availability. So 404, all of us know what is 404?
Not found.
Not found. Good. Which is a part of being unavailable. What is 403? 403, 401, anybody?
Permission unauthorized.
Okay, so these two are related to auth. Okay, and then 429 is again related to rate limiting. So whenever availability kind of problem is there, 4XX HTTP status 4 series status code comes. When internal server error related problem happens, then 5XX error code. Okay, 500 is exactly internal server error. Similarly, 501, 502, 503. 529, 5, whatever is there. So these are defined. You can come up with your own status code, get it approved by HTTP community if you have a valid use case. So, but this is the point. 4XX this purpose, 5xx this purpose. What about 2xx? Any guesses? What is 2xx used for? 2 series. This is success related messages. Okay, 200, 201, 202. And I don't know how many know what is the 3 series used for.
Redirection.
Yeah, this is for redirection. Okay, so you redirect the request to something, then you send a 300. Successful redirect is denoted by 3x. Okay, so you should know these, because if you give this data points, then it adds to what you are saying, right? You know what you're talking about. Okay, so rate limiting we have already covered the entire class. Now the way we are moving ahead, we will be leveraging on our building blocks that we have already solved to solve harder problems. So again, I will not be revising this. Go and watch the previous class recording. You'll get an idea about it. So validation of request will be a responsibility of notification service. Fetching client info can be done now. It's just freed up to do this. Rate limiting can be done. We had a reliability point as well. How can
DB as well here?
Sorry, I didn't hear you.
You have also used your DB with notification service.
Yes, this is for the fetching the client information. Okay.
Okay.
So notification service can store notification related client information like phone number, device token, and whatever is needed to send a SMS email address. So they can store. So now why it is storing? So for example, you want to call notification service, you are billing service. So billing service has customer ID. Now billing service will not find the email ID and send to notification. What it will do, directly send that this is the customer ID. My payload is email. This is the text of that email. Send the email. So for notification system will get the customer ID, fetch the email address for that customer, prepare a HTML message for the email, and then send it. Okay. All of that we are yet to come. But yes, to answer your question, this database is used to get the client info, which can be email, mobile number, or device token. Okay, so we will come to it. More points we can add on here later. You don't need to know everything right now. But now, good thing what we have done, we have freed up our notification service. Its responsibility is not to send the customer till the last mile. It is just to package the message and send it to the messaging queue, which gives it time to do other things mentioned here. This is a very important thing that we have solved. So far, there is no messaging queue here. We will see if required, we'll put one here. So now my latency of per request has gone sharply down. It will be somewhere in milliseconds, 5 milliseconds, 3 milliseconds, something like that. Because the database and the messaging queue will be in the same data center where the network notification service is hosted. If I'm using Azure, then all of this will be a part of one resource in Azure, located in one database, one data center, which means the network lag will be extremely low. And if you have done my first few classes, then you know that network lag is mostly the real culprit in most of the latency scenarios. So without going them again, I hope you are able to do 1+1, and now you are able to understand that putting a messaging queue on left side versus right side makes a hell lot of difference, right? So the right side one makes more sense. Okay, so you also need to know where to add a messaging queue. Now, messaging queue won't, you have somebody is pushing to the messaging queue who is popping or who is reading from the messaging queue. Okay, so this is called publisher, and somebody has to be a subscriber for the messaging queue. That part we need to still crack. Okay, but what will be the role of this service worker, whatever? What will be the role of this guy? What all will be the responsibility? Because message sending is still done by our third party solutions, APNS, FCM, SendGrid, Twilio. So what is the role of this person?
Filtration based on priority or type of notification.
Good. So firstly, one role can be classify, right? Classification. So basically it has to have a mapping like email then sent to this third party, right? SMS then sent to this third party, push notifications then sent to this third party. Again, depending on iOS or Android, different. So Using some mapping, it has to classify and redirect. And also I'll note that some mapping has to be here, static mapping, to find out this to solve this problem. What else? What else will be role of this component? Let's assume this is also a service. What will be role of this service apart from this?
Any priority we need to consider?
Good point. Right now, let's say no priority because in requirement we have not kept, but that is a really good point. We can add that as a good to have feature.
Also, based on the scale, it should be auto scale type of feature.
It should be scalable. Yeah, that is given. Main roles. Reliability. Where do you think reliability will come in? Can it come in as notification service? Or
retries and all this.
So reliability, so that is part of reliability and robustness. So it has to retry. What else? If it retried and failed, then 3 times, 4 times, 5 times it retried, whatever X number of times it retried, and it failed. Then what it will do? Should it
inform caller?
It has to inform, right? So it has to say success, failure. It has to. How will it tell success and failure? Because assume you are a service, you sent a request to notification service. Notification service returned a response to you, 200 okay. I have received your request. I'm processing it. That's it. Now, while processing it, it failed because let's say phone number was wrong. Okay. So this service or worker will have to now notify S1 somehow that okay, we have failed sending the request, or somewhere it has to do something for S1 to know that yes, whatever I sent was not able to send because of XYZ failure. So with the log error message that it has got from the third party, it has to inform S1 that I could not send your message. If it has sent a message, then how it will inform. So we need to think that how we want to inform. It will be a bad idea that this worker starts doing HTTP calls to S1 to tell him success or failure. For example, you write something in database, it gets written, it gets failed, you get to know it then and there, right? Rather than database sending you email notifications or whatever about. So that may be a bad idea in this case. So what instead it can do, we need to think. Okay, it can log this information and expose it as a dashboard that S1 can see. Okay, these many requests went through, these didn't go through. If the failure reason is permanent, then it has to notify that. So we will solve that problem. Okay, that we still need to solve. And the problem is of analytics, success, failure, right? Retries we can solve here. Classification we can solve here. Analytics we need to still solve. Okay. Another role of this service, fourth point which I was coming, was proper analytics. How many emails were opened? How many were clicked? Okay. So these information, how to collect, where to collect. This is the last piece before the third party app. So, or we want another app. So basically this is an open problem which is unsolved till now. How to get analytics information. So now with this work of this component, question mark component in our mind, we need to decide what this should be. Okay. So it has to be also fast and scalable. Okay. Because it has to honor the 5-minute latency. So now, what should we have? So let's say we have a service here, which is consuming from the messaging queue. What is the role of this service? One is to classify, one is retry, another one is success failure, another one, too many roles for one service. How can we reduce the role? Can we reduce the classify and redirect role? Let us go through them one by one. Classify and basically call the right third-party service. Can we remove this role? Is there a way? Because there are only 3 types of notification today.
Separate queues, sir.
Good point. One solution is to have separate queues. You can have separate queues for push notifications, separate queue for email, separate queue for SMS. And in push notification, some will be iOS, some will be Android. That or another XYZ, that needs to be figured out by this service itself. So at least some room you have given this guy to breathe. Okay, so this service will be responsible for the type of queue it is consuming from. That is point number one. Okay, so this way you can offload some responsibility here. What about retries? How should it retry? Let's say it picked a message, it failed. Should it send it 3 times again and again? In a good way?
delay.
It should add it back to the queue.
Some delay, with some delay.
One is added back to the queue. But how many times does it add it back to the queue? Every time it fails, it adds it back to the queue. If
Max
not,
try
how
count.
will it know? How will it know how many times it has
Max
added
try
it
count.
back to the No, but how will it know? For example, you consumed this message, it failed, you pushed it back to the queue. Next time it will come, it failed, again you push it back to the queue. Where do you store this count?
Some key value data.
So point is, you need to have a database, right? So now you are also having a database. Okay. So this is a good retry option, but do you see a problem with this retry mechanism? So you try to pop a message. If it fails, then you send it back of the queue. Will it fail the 5-minute guarantee? Let's say it took it 4 minutes to reach here, and then you said, now go back all the way back. It will take another 5 minutes to come to the top of the queue. So this may not be a good strategy. Okay, so this we will not do. What is another strategy? You pick a message, it fails to be sent, and then you immediately try 3 times. What is the problem in this strategy? This we all do, right? We all send an API request with some retries. If this is plain and simple logic, is there a problem with this logic? Let us understand this. Let's say service 1 and service 2. Service 2 sending request to service 1. Service 1 is running hot. It is running at full 100% CPU utilization. So when you sent an API request to service 1, it gave a 404 not found. Not found, let's say. Some error it gave, okay, 500 or whatever. Okay, that could not process your message. Timeout. Okay, this was the word that it timed out. Okay, it timed out with some error code. So if you have a retry mechanism, then what it will do? Once you receive this timeout, immediately you will send another message, timed out another message, and similarly other clients are also there. So instead of sending one message, now they are sending how many messages? 3 messages. Will this system, who was already running on 100% capacity, will it ever be able to overcome this? This is called exponential degradation of a service, right? Because everybody is trying to retry, and because you are running hot anyways, you are timing out, or you are not able to process the request, you have become unavailable, and now because of the retry mechanism, you are getting more and more requests. And let's say this S1 did not implement a rate limiter or whatever, this will never be able to recover from this, right? So what kind of retry can solve this problem? What change can you do in your retry mechanism to solve this problem? So this brings us to a next concept, which is called exponential backoff. Okay, what it is called? Exponential backoff. What is exponential backoff? Exponential backoff says that you retry. 1 minute, I'll have to take a call. Sorry.
Yeah, sorry. Back. Uh,
Okay. Am I audible? Hello.
Yes, you are.
Okay. Thank you. So now there's something called exponential backoff, which means that once you try to send a message, if you get a failure, you wait for 1 second before you send the another message. If it again fails, then you wait for 2 seconds. Then again, if it fails, next time you wait for 4 seconds. So what is exponential here? 1, 2, 4, 8, and so on and so forth. Okay. So this is called exponential backoff. So if you are, let's say, retrying somewhere 10 times or 5 times, then you retry it with exponential backoff. Then it will retry at 1 second, 2 second, 4 second, 8 second, and 16 seconds. So this will give the downstream service to recover. It will give some recovery time to that service. Okay. So this is point number 2, that the retries can be with exponential backoff. How do we implement exponential backoff? Do we hold the thread and do the backoff? What problem do you think if I sleep over this? Let's say I am sleeping over, I'm delaying it. For that, I'm adding a sleep and I'm holding the thread for 16 seconds. Do you see some issue with this design? So it will keep, if it keeps a request active for 16 seconds, which means it is limiting its capability to handle more requests. Okay. So a lot of parallel processing will be happening in the service, and eventually it will have the same problem which the initial design of notification service had. So if you are implementing exponential backoff, then you have to do it asynchronously. You have to not hold the connection and then uh, do the exponential backoff. Okay, so you have to have a mechanism in which uh, you can pick that message after 2 seconds, and in that time free up that thread to read another messages. Okay, so for to solve this problem, again you will need some more mechanism. Okay, how do you solve this problem now? Now, how do you schedule? This is a scheduling problem, right? Now I have to send this message to the third party after 2 seconds, let's say. So how do I send this again exactly after 2 seconds without keeping my thread busy? Okay, so that becomes another problem. So this is generally this is how we solve this problem, is that we do a asynchronous implementation where we asynchronously send a request, get the response. And if you have done asynchronous programming, then you will know that once you send a request asynchronously, the thread becomes free to take another request. Only when the response comes, then the thread again becomes busy in reading that request. Okay. So if you implement it asynchronously through and through, using awaits and asyncs, then you can still solve this problem by freeing up the main thread to read another request. If you are not following asynchronous paradigm of implementation, then it becomes a harder problem to solve. So this was a little knowledge on exponential backoffs. So they are always implemented using asynchronous programming. And what is asynchronous programming? Now, I'm not saying that you add a messaging queue here. It is simple. Asynchronous programming is simply implemented using awaits and asyncs. If you have written any API, now you know why those database calls etc happen using await. So that while database is doing its thing, you don't keep holding that thread. Okay. So the thread becomes free to take request, and the next time when the response comes, it becomes available. So asynchronously, you can implement exponential backoff. Now, this is still here. It is fine. Now, how does it detect success failure? Now, it can log the responses somewhere. The service has to log its responses that yes, it was a success, it was a failure, so that I can read this database S1 or S2. My providers can read this database to know whether it was a success or a failure. it can be publicly accessible letter. So this is one way in which you can notify success failure. And then analytics, it is still to solve. Okay. And fast and scalability, I think we have almost done it. So how it has become fast, we offloaded the responsibility by having multiple messaging queue. Retry is done asynchronously, right? And then we need to scale it, so we can add more and more servers here to scale it. Okay, we can horizontally scale it. Point. So now let us try to see where our design is going. Currently we have S1, S2, SN. You have notification service, sending requests to notification service. Notification service is sending the response to a messaging queue, which has messages, not one messaging queue, but multiple messaging queue. One for email, one for SMS. So for each type, you have one. And then from this messaging queue, you can have some workers or services. So with our use case, it seems like having workers would be better. So you can have jobs or workers assigned to each. They are assigned to read messages from each messaging queue. And then they can consume the messages and forward it to the third party layer, which will eventually send the message. Now, as we were discussing, we already discussed on the retry how we will implement the retry through exponential backup, how we will implement the success failure is via logging. So let us discuss that. So each of these worker will have a notification log, which will say whether it was a success or a failure. What else? Analytics is still left. So now let's talk about the analytics part. Okay. So the analytics part is the next part here, right? Analytics part is that once these third-party messages, okay, now have been sent. Firstly, analytics is, let's understand what we mean by analytics. Somebody sends a request. From request, it moves to processing. Not processing, like you can say, processing is a very vague term here. You can have some data points like the request has come, then you can have accepted by notification service, then it can move to messaging queue. So once it is accepted by notification service, you can assume it has been sent to the messaging queue. From the messaging queue, once it has been picked by the worker, then we can say that attempting to send. Once the worker receives acknowledgement that it has been sent, then it will be sent, or it can go to error. And once it has been sent, then it can be clicked by the customer. So this is the whole funnel that a person or anybody is interested in, to see what is the status of his message. Okay, so these are the statuses that people are generally interested in. So when a request is received that the customer anyways knows, so he wants this status accepted by notification service. You can call this state as pending or whatever you want to define. This state can be pending. This state can be also called sent, clicked, and error. They are fine. Okay. So we define 5 states: pending, pending, sent, clicked, and error. Now, all of these per message, we need to store this. So each and every message which is in process there has to be stored here. So how do we do it? For example, when we receive the message in notification service and we send it to the messaging queue, at that point, I need to notify someone. When I send it here, I need to notify. Then when it is being picked up from the messaging queue, then it has to be notified at this point. When it has been sent to the third party, then it has to be notified that yes, it is sent. Then when the message is clicked by a customer, then it has to be notified. Okay, by that device, somehow we need to be notified that yes, click has happened. So from each of these part, so this part, this can be sent by the notification service. This can be sent by the, whenever a request is picked up, it can be, this event can be informed by this worker. Once the event is forwarded to third party, it can raise the event called sent, and then devices have to somehow send this clicked. And all of these events, we can have another system called analytics service, which receives all this data. Okay. Of course, it will have its own DB and all, database etc. But this will be offloaded. So now, how we scale it? So we offloaded this responsibility. We offloaded this responsibility so that the amount of work this is doing is not high. Okay. So now analytics service is doing that. Now the interesting part is how does a click event, how is a click event notified back to the analytics service, right? How do we design such a thing, right? Let's say you opened your email, then how do you get a response back to the person who has sent it that yes, something has been sent? Or if you open SMS, how is the event triggered? So again, this is something which a platform has to support. For example, SMS opening etc. Now Android may send an event back to the servers whenever something is happening. Apple may not. On emails, however, there is a way in which I think you all know. So there is an invisible pixel which is sent with all the emails. And once you open an email that is sent as an image file, so it gets downloaded. And whenever that image is downloaded, an event is sent to the server. So these are some solved ways in the industry to know that whether an event has been, whether an email or any notification has been clicked or seen or not. Okay, so through this you can get an event to your analytics service. So now, what is our design? So basically now our design, let us complete our design. Our design is that we have a notification service, then we have a messaging queue, multiple messaging queues. We have workers reading from these messaging queues, many workers. We can scale, add more workers. We'll come to that when you have to add more worker. Then you have a analytics, sorry, not here. Then you have a analytics service, which receives events from notification service, from workers, okay, and from the client itself. These send the notification to a bunch of third-party entities like APNS, FCM, SendGrid, Twilio, and then these finally receive to clients. And clients send these click events back to the analytics service. Analytics service can have its own database, and now what will the end-to-end behavior is? Let's see. That as a service, you send request API calls to notification service. Notification service gives you a response 200 OK. If it accepts your request, once it accepts your request, it forwards the request to a messaging queue. At the same time, it also sends an event to analytics service that with an event state called pending. After this, the message remains in the messaging queue, and then the individual workers start pulling the messages. This is step number 3. Once a message is pulled by a worker, it sends an event called sending to analytics service, and then they actually also send the event to the third party. Third party app send to the client. Client send a click event back to the analytics service. Analytics service received pending, sending, click these data. Of course, error can also happen. So sending and error both are sent by our workers, and this is the end-to-end design. So now, if S1 sent a message and it failed, it can look it up in the analytics service. Okay. if anybody wants to inquire about any message which has been sent or not, they can look up in the analytics service that whether it has been sent or whether it has not been sent. Now, each of these workers also maintain logs, which can be failure logs or whatever, and they keep it so that tomorrow, if you want to investigate any failures, then they can do. So logging we have taken care. Now comes the most common interview counter question that may be asked there: that when do you know that you need to scale the workers? Because unlike a simple service where if more requests come, then you scale, automatic scaling is also there. In this case, you are reading from a messaging queue. Messaging queue will always keep the data. Here, you have to increase the worker to honor the 5-minute latency. So how do you not understand that, yes, this is the point where I should increase the number of workers? How do you guarantee the SLA of sending a message and keep it to 5 minutes? How do we do it? So here, an interesting metric that you need to, anybody was saying something? Yes, go ahead.
So the message, the how much it is occupied, and the timing can be used.
Good. So basically, you are interested in the size of messaging queue. How many messages are there in the messaging queue, right? So what you can do here is that you can again capture this metric. So if you are using a hosted messaging queue, like an event bus or RabbitMQ or whatever, if they are available on Azure or AWS, then you can have metrics and alerts on them, on the amount of data. So you can set an alert that if the amount of messages in the messaging queue exceeds X, then page me. Okay. And when you receive a page, and this X is such that it guarantees a 4-minute SLA, let's say. Before 5-minute customer SLA, you receive a page. And whenever you receive a page, you see that, okay, this is a page because the messages in my messaging queue has requested as X number of messages. So which means that the consumption is not as quick as the rate of submission. Then you start scaling your workers on each of these. You like scale all your workers, all the 3 types of workers you can scale. So this is overall how you should design your system. Okay. So you have a worker layer here, you have a messaging queue layer, you have a service layer here, and again you have one more service, which is the analytics service, which is basically storing this message ID. This is the status, and it will store all the status, right? For like one message, let's say M1, it was pending at 0800. M1 was sending at 0802. M1 was sent at 0803. M1 was clicked at 1004. So all of this data will be now visible to, if it is error, then error. So now that problem is also solved. That how S1 knows if a message sending failed. So they will know from the analytics service. Okay. And our workers will always log their responses. And this logging is very important so that because we are interacting, this is the gateway of interaction with third party. So tomorrow, if we want to raise a complaint to third party, then we must have these logs here so that we can raise a query about what is or anything. Okay. So this is again important to have logs at an interface where you do not have any control on. And this is the overall design.
One question. Why are we not having an MQ in front of the notification service? What is the reason you mentioned? Why what I was thinking is we can have both on the right side as well as on the left side.
You can have both, but now we solved the problem. So firstly, why did we need a messaging queue? We need to understand that we needed a messaging queue because notification service per request had to do a lot of things. Right? It was taking 5 seconds. Initially, we started with that. So right now, notification service is not doing that much work. Right? Notification service main work is receive a request and send it to the messaging queue. And there are a few small work like get the client info, etc. So now we have anyways per request latency on the notification service is now anyways now reduced to milliseconds, couple of milliseconds or 3 milliseconds. Because now it is simply like it is not doing a dumb job, right? It's taking a request, packaging it in a message and sending it to the messaging queue. Of course, some embellishment it is doing it on top of it, like getting phone number, mobile number, email address from a database lookup, which can be also cached. So you reduce the time
Right.
to one
No, the reason I
request.
was thinking of on the left side, if you have a message queue, it will also remove some of the duplicate messages sent by the same service. Some of those, notification duplicates can be removed through intelligent ways. So on the left hand side, if you have an MQ, that will help. Remember the same way we
That's a
discussed.
good point. But to yeah, so see, firstly, you can have a messaging queue. Point number one, you can definitely have a messaging queue here also. But again, you need to see that if you have a messaging queue here, messaging queue also comes with some cost, right? Also, it comes with some delay because messages will pile up. Now you also have to set an alert on the size of the messaging queue etc. So scaling networking notification service as your client scale, it is a good idea so that you at least you can auto scale here. So see here we already faced the challenge that we have uh, not a good way to scale our workers. We have to some alerting and paging has to be done to know that messages are piling up in my messaging queue and we need to add more workers. Same problem will come here also. So messaging queue also comes with some cons. Pros are there, cons are also there. Now the problem of duplicate messages that you brought, that can be solved. How that can be solved? So you can have a message ID for each message, which a client is sending. And if that is unique, then only you send it. And that can be very well validated in notification service. I think one of the validation was one of the work of notification service, if you see, was validate a request. So as part of validation of request, you can also see that if that request has been already processed by notification service or not, and that can be stored in a database. So you can solve that problem in that way. Generally, I use a messaging queue only when I see that the rate of incoming and the rate of outgoing is mismatched. Here it is not. Rate of outgoing is as quick as rate of incoming because per request latency has reduced. So here I would not. Why did I have it here? Because here the interface is dealing with a third party, which I do not have control of. So here I had to definitely have. We discussed in the beginning. Here we can't live without having a messaging queue here because I can't control the latency which APNS, FCM, or SendGrid is having. So there I must have a messaging queue and a worker that I can scale because I can't scale the third party service. I can scale my workers. Okay. So this is the logic for that. So overall, this is this is another base or a foundation on which we'll build on. So every system design will have a notification component. So now you also get an idea about how notification components are designed. All types of notification, whether it is SMS, email, phone call, even phone calls, let's say, right? Tomorrow, this was one thing which I was going to add now. Let's say now your notification service, this is called extensibility of a design. If you want to extend the design to phone calls, then what extra change you have to do here? Firstly, a third party app will come, let's say phone call service, which will be added here. Now, this phone call service has to be like some worker has to process this. So you'll have a fleet of worker to this. You'll have a separate messaging queue for that. So now notification service will receive a phone call request sent to the messaging queue. Your workers are consuming and calling the phone call third party service, and a phone call is received on the client. That's it. And if a phone call is received, send it back to the analytics service. So now this is scalable. You did not go and change in all the existing component, just had to add a new messaging queue because you have a new notification channel. You added a new fleet of workers to consume the messages from the messaging queue, and that's it. But this is also extensible design. Okay, so let me go through some questions that people have asked.
One more
So one
question I
question
have.
is,
If the
okay.
phone is switched off, right? Will you receive the what happens to the success, like from Twilio, whatever that service is? Your phone is switched off. Would you get a success or a failure, or unreachable? What would be the message?
Yeah, so Twilio will send us error, right? That it could not send a message.
Okay,
So
thanks.
that will be logged by the, yeah.
Okay.
Okay. So now let us come to the other question. So one question I am seeing on chat that has been asked is, what if messaging queue response is slower than expected? MSMQ response is you like I may need some clarification on the question. In the meantime, let's go to the next question. Just okay, what is difference between a service and a worker? Good question. So one question, yes, Jitendra, I will come to you. Before that, let me answer one quick question. What is difference between a service and a worker? Okay, service is basically a 24/7 available server which is running. Worker can also be a 24/7 available entity running on a server. Okay. Now the difference between worker and a service is that service is generally also a point of contact to external world. So you call something a service if it is interacting with other upstream and downstream services. You have workers if inside that service, for example, in this case, notification service is our single point of contact for external world. So it is working on the principle of REST protocol CTC. It has to follow that convention. Workers have no such obligation. Okay. Its only job is to read messages from messaging queue and forward that and call the third party service. Okay. No external. So S1 or S3 can't directly call our worker. Worker will only run as part of the entire notification system, right? Which is this, the messaging queue, notification, and worker. So workers and services, firstly, workers need not run 24/7. Workers can be jobs, okay? They can be run every 1 hour, 2 hour, 3 hour. In this case, it depends on your load. You can decide that. Even if it is running 24/7, services will need to mandate some protocols, etc. A worker does not. So this is the fundamental difference. Workers can also be are also lightweight processes. They can run on multiple, like in one machine, multiple worker threads can run, or some lightweight servers can be allocated for workers because workers do simple jobs. They don't do very hard, heavyweight jobs. Okay, simple jobs like generally, typically reading from a messaging queue is always done by a worker. Okay, because it has to read the messages and forward the response somewhere else. So these type of jobs are done by workers. So a good thumb of rule is that if there is a external point of contact, and if you think some definite protocol etc has to be established, which is happening in case of notification service where you're receiving request externally, if you are not exposed to the external environment, and external does not mean customer, it can be internal external teams as well. Okay, so inside a system you can have workers instead of services. Okay, and they are fundamentally different. The way they are hosted, the way they are scheduled, the way they work are quite different. Okay, so workers are lightweight jobs that can be scheduled or can run 24/7. That is the definition of a worker. Okay, I hope that answers your question, Harsh. Shavana is asking, what if subscriber get message delivered late? How to? Okay, so we have workers, right? So we had a metric that if the number of messages in our messaging queue exceeds X, then we notify, which helps us to know that this is a time to scale our workers because the amount of pending messages are increasing. So we can scale the number of worker nodes here, which can now parallelly process a lot more messages. Okay, they're all parallelly reading the messages. So they will parallelly start consuming more and more messages. And if you scale there, horizontally scale your worker nodes, they'll read more and more messages. So your rate of consumption will increase and will probably match, become equal to. In a stable state, it should be equal. So rate of publishing should be equal to the rate of consumption. And once that becomes equal, then your queue will not overflow. So that's how we solve it. Okay, so this is all you need to know. One more question is there, is on service level limitation. If Twilio can accept only 50 calls per minute, but workers send 100 calls. Great question. If Twilio can accept only 50 calls per minute, but workers send 100 calls, then workers keep failing. How it can be handled? So the question is that what if third-party apps have some limits? So how do we make sure that the workers don't breach that limit? Anybody wants to answer that? If the workers are sending excess amount of request, how can we reduce that amount of request?
Rate limiting.
One is rate limiting. What can be other things? So for Twilio, let's say it is accepting 50 calls per minute if you have one subscription. Firstly, there you can scale. You can have multiple Twilio subscriptions because you also have your 5-minute SLA, right? If that can become a bottleneck. If you are only processing, if you reduce the rate here, then my last message can take more than 5 minutes. So here, that's a good point. If you are breaching the limit, then buy more subscriptions, right? There is no limit if you are willing to pay. So pay more, get more subscriptions, increase your limit, and make sure you are directing the message to the right subscription so that 50 per limit is not breached. And here you can have a rate limiter to know that if per subscription you are breaching the rate limit or not. Okay. So that rate limiter can come here. It's a good point. Okay, so that you can do. That may solve your problem here. Another question is, can we model notification service as Apache Airflow, AWS step function? That way we don't need to manage queues, scale up, down. Okay, so using Apache Airflow / AWS step function. I think you are talking about AWS lambdas here. What do you mean by step function? Apache Airflow is the, can we model notification service? Okay, so you mean this notification service as an Airflow or AWS step function. We don't need to manage queues and scale up and down. Jitendra, can you clarify your question? I have some counter questions here, if you are available. Okay. First question to you is, like, you're talking about notification service. So in that, if you have AWS step function, then how do you ensure availability, that your service is always available to take request? Okay. Second point is Apache Airflow. Then you'll have to tell me some detail about Airflow. I think Airflow is a scheduler. So, like, what do you think? What are you proposing there? Some questions there. Okay, if you can clarify those, I can answer. Okay, so this sums up what I had to discuss for today. Next class, we will discuss chatting, real-time chatting. Okay, so like WhatsApp chatting, etc. we will cover there. Previously, I had discussed before ending today's class, I have some time. So previously, we had discussed the key value store design, right? In which we covered design of AWS DynamoDB, Cosmos DB, etc. So on that line, there is a quick demo that you guys can leverage, which we have created. So we will talk a little bit more about that in our live batches. This is a tiny URL that we have made on Azure using Cosmos DB. So we will cover this design, but we will cover this design in a different way. This time, so maybe you can click, I have pasted a link on your chat. You guys can open that, and I will stop share and reshare my screen. Okay. Are you guys able to see my screen?
Oh, yes.
Okay. So this is a small demo that we have made. I will discuss this in more detail in the next class. So here is the basically we will cover the design of a tiny URL or a URL shortener. And we will not just cover, because the design problem is very basic and everybody knows about it. We will go through the implementation. How do we implement it? How we procure Cosmos DB database? How do we host it on Azure web app? And a lot of challenges that you may face here. Basically, you give me a big URL, you write the URL in this box, submit it, you get a small URL, and that URL works as a proxy to the actual URL. Okay. So if somebody can give me a big URL, if not, then I can just choose a smaller URL, let's say google.com. But this is not for this use case. Basically, when you have a very big URL, which you want to stop, you want to stop, I'm saying, if you want to shorten, then you will use this. Basically, you submit it, you get a tiny URL for this, because the actual URL was also tiny, so it does not make sense here. But once you click this, you'll be redirected to google.com. Okay, so this design we will be covering end to end, how we implemented this, how not, to understand the role of a URL shortener. I can give you a quick example. Let's say you go to Amazon, and inside Amazon you go to, let's say, purse, and then here you will see links are very, very big. So let's say you search for something, let's say a bag, and you want to give this link of the customer reviews to someone, and this link is huge. Okay, so I will paste the link in chat. So this link you can see is huge. Now you want to send this as a link to someone. So this is huge. So how do you send it to someone? So what you will do, you can shorten this here in what we have made this. Get this URL, and I'll paste this URL. And now you can click both the links, and you can see that both are redirecting to the same page. Okay. Okay. Click the original link as well. So we made it from scratch, and we'll be covering it, going through the design of URL shortener. This will be done in the next class. So agenda will be changed. I want to give you guys practical experience, not just theoretical experience. So I will take you guys through the code that we have, the Cosmos DB client. How do we create it? How do we create the controllers? How do we design a database interface? How do we have a key value store? What is the MVC architecture? How do you publish something on Azure and whatnot? So I think this will help you guys a lot. This is a real life project, which this is what you work in a job. This will help you upskill in true sense. Now you don't have theoretical knowledge, and we will cover the key value consistency issues that we had faced previously by going through in Azure, how we are using Cosmos DB, how we are procuring Cosmos DB, what is read capacity units, how did we procure it, what is the partition key that I'm using, and all of that we will be covering. So that will become a good exercise for all of you. Okay. So does that sound interesting to everyone? Okay, so we will cover that. Yeah. So if there is any question, you can ask.
Hey, I have a doubt. So since we were designing with the 100 requests per second, what if we want to make it we have to increase the scale up of 1,000 or 10,000 requests per second? So we need to horizontally scale it, right?
Yes, we have to horizontally scale it. So why do we estimate? Firstly, so we estimate, for example, assume that we wanted to send 1,000 requests daily. Okay, let us go back to, okay, let's imagine, you all know the design now. We had a messaging queue, we had a service, we had some workers, and you had to only send 1,000 requests per day. Remember the first design that we had, right? Without any messaging queue, requests were coming and we are directly sending that request to the third party, right? So if the requests were so low, that 1,000 requests per day, which is 1 or 2 requests per second, then the first design itself would have qualified as a correct answer. All right. Because the requests were of the order 100 requests per second, and it could have increased in future, that's why we went with a scalable design. So to answer your question, Yes, we will horizontally scale. And this may not be, and why I'm saying this may not be always. You may end up in an interview where and we will cover those type of problems also, that you will see that the maximum scale that the system can get, in best case, is 1 or 2 requests per second. So there you don't do these engineering. There you have a monolith and save your money and move ahead. Right? You don't deploy money without a need. You need it when required. So that's why we do back of the envelope estimations. Another reason why we do back of the envelope estimation is that this design works for 100 requests per second. What if it is 10,000 requests per second? The design can change. We may have to add caches. We may have to add more messaging queues. We may have to add a messaging queue before, like somebody was suggesting. Why not add a messaging queue between services and the notification service? Yes, we can add if the requests were that high. So the design changes when the scale changes by an order of magnitude, not by 100 to 200, but exponentially when change happens. 1 to 100, 100 to 1000, 1000 to 10,000, design changes completely. Okay, so that's why back of the envelope estimation helps you know that what kind of scale you are doing. Hope that answers your question.
Thank you.
Okay. Okay, so thank you all. Okay, I will respond to all your messages. I hope I have responded to all your messages. There are some other questions which I will respond later. That's all for today. I also have nothing else to cover. Yeah. Tell me.
Anil, I sent one message, not related
Yeah.
to the lecture, but other.
Yeah, I read it. I will get back.
Okay.
Spotify team will get back to you. I read it.
Okay.
I have noted
Sure.
it down.
Thanks.
We'll get back. We have some ways for that.
Okay.
Okay. Thank you. Thank you, everyone. So next class, which is tomorrow, I will be going through the code and I will be covering that, how to design a tiny URL. And maybe next class or maybe next to next class, let me decide that how much prerequisite knowledge you guys need to have before implementing. So let me take that call. So I will let you guys know when we have that session. That session we will have, and I will share the GitHub link and etc. You can explore that. That way you will get practical knowledge on how to build anything end to end. Okay, so that will help you familiarize with Azure, AWS, etc. Okay, and feel free to use that URL to, if you want to shorten anything, you can use it. It's as good as bit.ly. Okay, highly scalable. We have created it on Azure. Okay, thank you. That's all for today.
Anil, just one question, like how do we subscribe to these classes? Like what are the fees and how do we do it?
Yeah, we will get back. We will get back to you. I think you have joined today as a demo class. So this is a paid live batch we are having. So you will have to, our sales team will get in touch with you. You can join us in our batch. Our batch runs for 3 months where we cover system design from basic to advanced. So our sales team will get back to you, Prakhar. I have noted your request and your number.
Sure.
Okay.
Hey, this
Okay.
recording
Yeah.
links are shared anywhere?
Recording will be shared in our self-paced course, which is a paid course, 1999. Their recordings are set. We generally do not share recording for security and privacy purposes as well. Thank you.
Thanks.
Okay, so thanks a lot, everyone, for joining. Today I will end right now and give 15 minutes back to you guys for the weekend. Have a good weekend. See you guys tomorrow. Thank you. Bye.
Thank you.
Recording stopped.